In this video, I'll be demonstrating how to perform a one-way MANOVA. The data set we're going to be using has 4 outcome variables, and these are variables that are measuring levels of confidence on performing a task, competence on performing a task, the stress associated with performing a task, and then a rating of the overall team competence. So this study was conducted in order to improve team performance for a group of individuals that have to do projects as a team. The group went through one of three different types of training. One type of training was designed to improve team communication. Another type of training was designed to improve general work skills. And then the third type of training was training on team collaboration. So after the groups went through training, they were assessed on their level of confidence in performing tasks as a team, their rating of their level of competence in performing a task, the level of stress associated with performing tasks, and then a rating of overall team competence. So for confidence for a task and competence for task, the higher the score, the more the individual felt that attribute was present. And the same for team competence. For task stress, the higher the score, the more stress is also what's being rated. And so we're going to attempt to do a one-way MANOVA and looking at the group differences on these potential 4 outcomes. So one of the first things we need to do is make sure that we're meeting the assumptions that our dependent variables are related to a certain degree to one another. They need to have a certain level of relationship, but then they're also not too related. So we want to look for Pearson correlations between our outcomes that fall between 0.3 and 0.8. So we want there to be some level of correlation, but not too much correlation, because that could indicate redundancy or what's known as singularity. So the first thing we want to do is go ahead and perform a Pearson correlation analysis. So we're going to go ahead into that menu, and we're going to enter in as variables our 4 potential outcomes here. Go ahead and click confirm, and then click calculate. And so we're going to go right to the raw output so we can see our correlation matrix table. And so what we're looking for are, again, is values greater than 0.3, but then values that are also might potentially be greater than 0.8. And so we can see here this first combination that's below 0.3. This one's above 0.8. That one's above 0.8. This one looks promising because it's in that 0.42, so it's kind of right in the middle, as well as this one. And then we can see this bottom combination of variables is quite high. So we're going to first look at these 2 as good potential candidates for including as our outcomes. And so as we look here, task competence and team competence meet that criteria of above 0.3 and below 0.8. So these 2 look like they would be good candidates. And just above it, we can see task competence and task stress also have a good relationship here. But if we look just below, we can see that task stress has a high correlation with team competence and also has a high correlation with task competence. So that stress variable is probably not one we want to include because it does have higher correlations with some of the others. And so it looks like our best option for our 2 variables to include as outcomes is going to be task competence and team competence. So we're going to have 2 outcome variables, in this case 2 dependent variables. So now that we've identified what our outcomes are going to be, and we've identified which ones would likely not be appropriate, we're going to go ahead and run the MANOVA. So we go to the analysis menu, choose the one-way MANOVA option. We find our dependent variables box. So we've got team competence and task competence as our 2 outcomes that we want to include. Click confirm. And then our independent variable is our type of team training. And we click confirm. And then calculate. Okay, so as we look at the raw output here, the first thing we want to look at, obviously, is the main effect for our training types relative to the dependent variable as an aggregate. But one thing we also want to look at and track is whether or not we've met the assumption of homogeneity of covariance. And we can see here the p-value is less than 0.05, so we did not meet that assumption. So we want to note that as part of our limitations relative to our analysis. We did not meet that homogeneity of covariance. So we're going to assess Pillai's trace for the overall MANOVA F table. So as we go to the MANOVA table for the overall effect on the aggregate variable, we can see our F score is 98 and our p-value is quite small, way less than 0.05, and here's the effect size for that effect. So that's a very large magnitude of effect. So for the two dependent variables in aggregate, we can see that the type of training the teams went through had a significant main effect on the dependent variables as an aggregate. So that's going to trigger then our ability to look at each dependent variable separately, individually, to see what effect the independent variable might have had on that outcome individually, all by itself. So let's look at team competence first. So we're going to go down to the ANOVA table here, and we can look at the F value and then the p-value, and we can see that that is way below 0.05. So type of training had a significant effect on the rating of team competence. And we can see here that we have a very high effect size as well. And so as we look at the means for each of those groups for team competence, the rating for team competence, we can see the group that had team collaboration skills as their training had the highest value, their work skill improvement slightly below that, and then the team communication training group below that. So now we know there's a significant difference somewhere among these three groups based upon team competence. So now we're going to do a post hoc for this individual dependent variable analysis. And so in order to do that, we have to go and actually do a one-way ANOVA to do this particular post hoc for this particular outcome variable. So we're going to go to the ANOVA table or the ANOVA option, choose ANOVA, and then so we're going to choose as our outcome variable just the team competence. Click confirm. And then our independent variable stays the same. It's our team training. So now this will allow us to tease out the effect of the training on team competence all by itself. And then we click calculate. Okay. And we already know that we have a significant main effect for team training for our outcome of team competence, but what we're most interested in seeing are the post hoc comparisons so that we can actually look for significant differences among those or between those three groups. And as we look at this, we can see the p-values that all three groups are showing significant differences between each other. And so the team collaboration skill group is significantly different from work skill and also significantly different from team communication. And then we can see that same pattern for the other groups. So all three groups are significantly different from each other based upon this rating. Okay. Now, the next thing we can do is go and look at the individual analysis of variance for the second outcome, which was task competence. And we can see that that one was also significantly different. Again, a large effect size, and here we can see the mean scores for those three groups. So it appears that for task competence, the team communication group had the highest rating, followed by work skill, followed by team collaboration skill training group. So we would do the same thing then. We would go in and do a one-way ANOVA so we could look at the post hocs for task competence being our outcome, and then we would interpret that in much the same way, looking at the effect size. If we had a clinically important difference value for these assessments, we could examine that to give us some idea of clinical significance. And then we could also look at the confidence intervals for the mean differences between these groups to see if they cross zero or if there's any overlap between those differences. So that is how we would go about doing a one-way MANOVA if we had significant differences for the aggregate DV as well as for the individual dependent variables. Obviously, if our aggregate dependent variable is not showing a main effect, is not significant, then we would not need to do these additional post hocs as I've demonstrated, and we'd be able to stop at that point. This demonstrates how you would go about assessing, first of all, the main effect on an aggregate, main effect on individual dependent variables, and then doing the post hocs within the main effects for each of those dependent variables independently. So hopefully you found this to be an instructional video, and if you've got any questions, let me know.